Okay, grade, what is it? Grade 10. Yeah, grade 10, grade 10, grade 10, grade 10. I think let's play it from the back. Let's play it from the back. Let's play it from the back. Play it from the back. Play it from the back. Okay, play it from the back. All right. Alright, so guys, we'll play it from the back, and then I am mindful of any requests you may have in the comment section. So if there's any specific requests of specific topics or things that you'd like covered, I'm aware of those. If you will type them in the comment section, I'll write them on the side. But I have like an activity document that I'd like us to look at here that is based on functions. Who is this person? Bernard. Bernard. Guys, don't request and do what you're doing, because I don't really like what you guys do. Okay, I don't really like what you guys do. Request, and please, if you request, be willing to come and join. Okay, so guys, what we are going to do is we are going to look at these function questions very quickly, and then we are going to move back to the beginning and do concepts related on numbers, expand and simplify, factorize, addition and subtraction of fractions, exponents, solve for x, inequalities. We will do those kinds of things, but I'm gonna start at the back with functions, because functions is like obviously the topic that most people have only done now near the end. Some people have, but some people have not. So I'm just going to look at some function questions, and yeah, let's just check and verify that we know how to do certain things that are functions related from the grade 10 syllabus. So let's look at the beginning. We have f of x is equal to x squared minus 1 and g of x is equal to x minus 1. So f of x, guys, is a quadratic or parabola function. How do we know that? Because the parabola function is given in the form x squared. If there's an x squared and the x squared is in the numerator with no other variable of x, then that means this is a parabola, a quadratic function. The form of that function is given by f of x is equal to ax squared plus 2. Okay, so here our a value is 1 and our q value here is negative 1. This is a parabola function. G of x is equal to x minus 1. This is a straight line or linear function. It is given usually in standard form in the form of y is equal to mx plus c. M, we call it the gradient. C, we call it the y-intercept. So here they are saying sketch the graph of f and g on the same set of axes. So both of these functions, they are asking us to sketch them on the same set of axes. So what we do, guys, is that f of x is equal to x squared minus 1. We can actually sketch this function using a concept which we refer to as the dual intercept method. Both the parabola and the straight line can be sketched using the dual intercept method. And the reason why I say so will be explained just now. So let's just take this function f of x is equal to x squared minus 1. Here, the coefficient of x squared is 1. That means as we sketch, we need to first look at what is the value of the coefficient of x squared. A is equal to 1, which means a is greater than 0. So in your head, what are you expecting? You are expecting to get a sketch, a function that has a concave up, or we say a smiling face, because when a is positive, any positive person smiles. So we call this shape of our parabola. When a, meaning the coefficient of x squared, is positive, we call this shape concave up. All right. So that's what we know about a. All right. Then 2, the y-intercept. Now guys, the y-intercept, this is where your function cuts or crosses the y-axis. The y-axis has an equation. The equation of the y-axis is x is equal to 0. The y-intercept, we find it by let x be equal to 0 in the function. So we say f of 0 is equal to 0 squared minus 1. We get f of 0 being equal to 0 squared is 0 minus 1, which is negative 1. So the coordinates of the y-intercept are, as x is 0, because we let x be equal to 0, y, the output is negative 1. All right. So far, from the coefficient of x squared a, we have the shape of the function. We begin with the end in mind. We know that we are going to sketch a function that has a smiley face, concave up. Then we find the y-intercept. We let x be equal to 0. The y-intercept is also, for the parabola in grade 10, is also referred to as the turning point. That is just in grade 10. The turning point and the y-intercept for the form of the function ax squared plus 2 is the same thing in our grade 10 functions. Okay, so your y-intercept and the turning point are the same. 3, we are now going to find the x-intercept. What is the x-intercept? This is where your function crosses, cuts, or overlaps the x-axis. There, we let y be equal to 0, because the equation of the x-axis is actually y is equal to 0. So for our function, we are going to let y, in other words, f of x, which means y, we are going to let that be equal to 0. Okay, remember f of x is just a notation that means y. Okay, it is functional notation, but it means y. So we let y be equal to 0, then x squared minus 1. We are now going to solve for who? For x. When we solve for x, we let y be equal to 0. This, what we see, is an expression. What kind of expression is what is on the right called? X squared minus 1 is what kind of expression? How will we solve for x when you have x squared minus 1? We call that expression a what? A difference of what? Of 2 squares. So that means we are going to open 2 brackets and factorize. We put a plus and a minus. The square root of 1, we put a 1 and a 1. The square root of x squared, we put an x and an x. Then, after factorizing, we apply the 0 factor law, because we have a product of factors equated to 0. So x plus 1 is equal to 0, x minus 1 is equal to 0. Then we solve each linear equation. We get x is equal to negative 1, x is equal to 1. Remember, who did we let y be equal to? We had let y be equal to 0. So therefore, our coordinates will be x is equal to negative 1, So -1 and 0 are the coordinates. 1 and 0 is your other coordinates. We call these guys, these two guys, our coordinates of the x-intercept. -1 and 0, 1 and 0. Now what you should notice is that your x-intercepts, if there are two of them, you should notice that the one value is positive, the other value is negative, but the numbers are the same. All right, one value is positive, the other one is negative. Okay, now that we have the shape, we found our y-intercept, which is also our turning point, we found our x-intercept, now we are ready to sketch the parabola. So what we do is we go ahead and we draw our Cartesian plane, y-axis, x-axis, you use a nice ruler, okay, not like me freehand. Y-intercept, remember 0 and -1. So let's just say our y-axis, our x-axis, we know there we have 0. So we're going to say -1 here. We are going to write +1 here. We're going to write -1 there. 0 and -1 are situated on the y-axis exactly where our y value is -1. Everywhere on this y-axis, our x value is 0. So the equation of the y-axis is x is equal to 0. Right? So now if you're going to go ahead and actually go and sketch the function, you have a turning point here. Then here you have your x-intercept. So this function goes like that, turns there, goes like that. Remember, we predicted and expected based on the a value that our function would be concave up. There is the shape, it agrees. Okay, that is our parabola, right? We can then label it and say f of x is equal to x squared minus 1, of course. Then, of course, we know that our coordinates here, all right, are simply 1 and 0, whereas here it's -1 and 0. And obviously there, our y-intercept is 0 and -1. Okay. Then, remember, we were also supposed to sketch on the same set of axes, g of x. Now, g of x is equal to x minus 1. That is our straight line function. All right. So once again, point 1, look at the coefficient of x. M is equal to 1. What does that mean? It means m is greater than 0. If m is greater than 0, that means our straight line function, we are expecting an increasing function. That is the expected shape or the direction of the function, since m is equal to 1. And obviously positive means an increasing function. 2, let us find now the y-intercept. Y-intercept, we let our x be equal to 0. Since it's a straight line, it's just the y-intercept, guys, where the graph cuts the y-axis. So all we do, we let x be equal to 0. We come to the function. We say g of 0 is equal to 0 minus 1. We get 0 minus 1 is a -1. G, when x is 0, y is -1. These are our coordinates of the y-intercept. Point 3, we find the x-intercept. Here we let y be equal to 0. When we let y be equal to 0, we go to the function. In the place of y, which is g of x, we substitute 0. So we displace g of x completely with 0, and then we say x minus 1. We solve for x, meaning we transpose -1 to the other side. The negative becomes positive, x is equal to 1. Therefore, our points for the x-intercept, remember, it was when we let y be equal to 0. So the y value must be 0, not x. Then x must be 1. Remember, when we write our coordinates, we write our x value on the left, our y value on the right. So those are our coordinates. Using the dual intercept method, we got the y-intercept and the x-intercept. So we sketch these points on the same set of axes where we had our parabola. Where is 0 and -1? Here. Where is 1 and 0? Here. So our straight line is going to go in that direction. Okay, so you would take your ruler, join these 2 points, and then you would exceed them, those points, slightly so that you can see the function, and then draw arrows on either end. That is your what? Your g of x function. You can then label it g of x is equal to x minus 1. Right, there's your y-intercept, there's your x-intercept. Those are my 2 functions sketched on the same set of axes. That's how we simply sketch, guys. And please take note of something here. Your parabola has a line which we call an axis of symmetry. All right. Y-axis is the axis of symmetry. Why do we call it the axis of symmetry? It's because the function for your parabola in grade 10 is always symmetrical along the y-axis. So the equation of your axis of symmetry for the parabola is actually x is equal to 0. That is always the case in what? In grade 10. Right? Yeah. Which is why if you come here to the x-axis, you actually find that on the same horizontal line, the x-axis, your x value on the left, the distance from here to there is the same distance from here to there. Because remember, if this is a symmetrical line, then it means this is the midpoint of your function for every horizontal line that you get. So for this horizontal line, you can see that 1, the distance from here to there, is the same. That is why here the x value for your x-intercept is -1, whereas here on this side it is +1. It's almost as if your points on the x-intercept are reflecting along the what? The y-axis. This point reflects along the y-axis, that point, and this point reflects along the y-axis, this point, on the same horizontal line. So that's why we refer to this y-axis as your axis of symmetry, the equation being x is equal to 0. All right, now let's move on and answer some questions that follow here. After sketching the graph, we are asked now, determine the domain and range of f. Now guys, they are saying f. Now you see this f and you're like, hey, what are they talking about now? So when they write f without the at x or of x, this f symbolizes the function f of x. So when they simply write f, guys, it's just a nickname for f of x. The nickname for f of x is f. The nickname for g of x is g. I mean, guys, a nickname usually, it's like in a nickname you omit something. It's like if you're called Lutando, then your friends will usually say, hail Tish, hail Tish. It's like they are omitting something because they want to call you in a familiar way. So in the same way, f of x, the nickname for f of x is f. So when they say determine the domain and range of f, they are referring to f of x. So just be mindful of that. Now, domain. When we say domain, what do we mean? The possible x values where your function exists. What do we mean by domain? The possible x values where your function exists. We are all writing tomorrow. Are we all writing tomorrow? Are we all gifting tonight? That's another question, Curry Pot. Are we all going to be gifting the creator tonight, or are we just all going to be watching tonight? Yeah. Look, here's the screenshot. So basically, this was the development of how we were able to get the a value, from the a value of the parabola, figuring out its shape, to the y-intercept, how we calculated, to the x-intercept, how we calculated, and then the actual parabola sketched. All right. Then this is for the straight line, from the m, the coefficient of x, what it basically tells us about the shape of the graph, to the y-intercept, getting it, to the x-intercept, getting it, and then to the sketch, joining the 2 points of the x and the y-intercept. And seeing, you see that it's the same direction as what we expected based on the gradient. Okay. Now we are here. What is domain? Domain is the possible x values where your function exists from left to right. If it's too late, then you can leave the live. I'm actually going to block this person here. Goodbye, goodbye, goodbye. If it's too late, why are you here? I mean, please, people, keep your comments to yourself, because I am actually really not in the mood today. Like, there are people who really want this help, and people just come here carelessly. If you don't have anything positive to say, please gravitate to the next live. I beg you to do so. The possible x values where the function exists from left to right is what we refer to as the domain. Okay, left to right. So when you look at this function, the parabola, this is f. The arrow here signifies that this function is infinitely coming from the negative side, and it's not stopping. Not stopping. All right. Then it comes down, it decreases from left to right. It decreases, but it's decreasing from where? From the left-hand side. It's decreasing from the left-hand side infinitely from the left-hand negative side. It's coming down, it decreases, then it turns, and then it increases, but it continues forever. The arrow here signifies it continues forever in that direction, never stops. So basically, when we talk about the domain from left to right, what are the possible x values where the function exists from left to right? Do we know, guys? And can we indicate in the comment section? What are the possible x values where the function exists from left to right? What would we say for this function, the parabola here? Possible x values where the function exists from left to right? We would say what? What would we say? Okay, I see the guys are very silent. This is what we would say. X is an element of real numbers. No, Lindo. -1 and +1, no. X is an element of real numbers. What does this mean? The function exists everywhere from left to right. Exists everywhere. Your parabola, there's no x value that you cannot mention in the number system where the function of the parabola will not exist. It will exist everywhere from left to right, because this function is unrestricted. So it will exist everywhere from left to right. That's why we say x is an element of real numbers. Remember, real numbers are all the numbers in the number system, both rational and irrational. All the numbers in the number system. So here, from left to right, the function exists. Yes, Oyama. Or you could say, if you don't want to write x an element of R, you could say, and it means the same thing as this. X is an element, you write open brackets, from -infinity to +infinity. That shows the function exists everywhere from left to right. This, guys, is the way that we write the domain of our parabola function. The function exists everywhere from left to right. Everywhere. For every x value that you can imagine, the function will be there. You can substitute any x value on the x-axis. From -infinity to +infinity, you are going to get an output value that signifies the existence of the function. The one x value will map onto another y value to show that it exists everywhere. So these are the two ways in which you can write the domain of your parabola if And this is the condition. If the parabola is unrestricted, if the parabola is unrestricted from left to right, okay, if it is unrestricted, okay, from left to right. Monroe light, why are you asking when am I going to do grade 10 again? All right. Maybe I can ask you, when are you going to come? When are you writing again? When are you writing maths paper 1? Because I'm guessing you're asking for that reason. Okay. So please, guys, let's get the domain down. What about range? Because they want the range as well. Range is the possible y values where the function exists. Next week, Friday. I don't worry. You can also, my YouTube channel will also help you as well. You know, I'll be uploading this onto the YouTube channel. You can always watch it when you want. But yeah, just let me know when you'd like me to go live again, and then yeah, because I go live in the evening. So yeah, if ever you need help, possible y values where the function exists from the bottom to the top. The possible y values where the function exists from bottom to top. That is your range. The possible y values. So you look at this function and you ask yourself, the bottom, what's the bottom of this function? Where does it exist? What is the lowest value that this function exists at? All right, and you can see the lowest value because your y value that is the lowest here, you can see it. It is that y-intercept, the value of the y-coordinate of the y-intercept, that is -1. That is your lowest value. But from -1 to where? As these arrows show, all the way, guys. Forever and ever and ever and ever and ever, no end to the top. So that's why we say when we talk about the range, we can write the range in interval notation and say y is an element -1 to infinity. -1 square brackets to infinity open brackets. Or we could write the range in inequality form and say y is greater than or equal to -1. That's another way of writing the range. So you have a choice when the function is concave what? Concave up like this. It means, generally speaking, y will always be an element of square bracket, the q value to infinity, open bracket, if it's concave up. Or we can say y is greater than or equal to the what? The q value, whatever the q value is. That's generally speaking for a concave up graph. What if the function was concave down? All right. Well, we would say, if we want to write it in interval notation, y is an element. Then we'd speak from, where does it come from? From the bottom. You see, this direction is very important. From the bottom to the top. Bottom being your lowest. So the lowest here, -infinity. Because -infinity indicates that this function is coming from a negative, low point to where? Okay, to whatever the q value is, the maximum. And we say square. So it's -infinity to q, generally speaking. But if we have the specific y value, then we say that specific y value of the y-intercept as the endpoint, you know, from to the top. So this function has a minimum, but this function has a max. Why? Minimum, lowest value. Maximum, highest value. Your minimum value is the q value. Your maximum value is that q value, meaning the y-coordinate of the y-intercept. Whatever the y-coordinate of the y-intercept is, that is actually our what? Our minimum value for the parabola in grade 10, the maximum value for the concave down parabola in grade 10. Very, very important. Or we could write the range and say y is less than or equal to q. You choose, guys. And I usually just say to learners, choose one way and hold on to it for dear freaking life, for now and forevermore. So please, guys, this is the explanation that we should have, an understanding we should have of domain, the possible x values where the function exists from left to right, is what we call the domain. If the function of the parabola is unrestricted, we say that x is an element of real numbers, or we can say x is an element of open brackets negative infinity to positive infinity open brackets, if the parabola is unrestricted from left to right. Okay, then the range is what we call the possible y values where the function exists from where? From the bottom to the top. Started from the bottom, now we're here. You know what I mean? Started from the bottom, now we're here. Range is always from the bottom to the top, not from the top to the bottom. No. Bottom to top, low to high. The reason when we say left to right is because left is low, right is high. That's the right reason why we say bottom to the top is bottom is low, top is high. So please, guys, if you choose interval notation for a concave up function, this one specifically, y is an element, square brackets, -1 to infinity, open brackets. Or we could say y is greater than or equal to -1. Okay. So please, guys, always ascertain. But if it was a concave down graph, we would say y is an element of open brackets, -infinity to whatever the q value is. Okay, which is the y-intercept, the y-coordinate of the y-intercept. Or we could say y is less than or equal to q. Okay, right, so that's just a little bit on domain and range. What if they had asked us the domain and the range of the straight line? The straight line is unrestricted. So if you look at it, the domain, from left to right, it seems the function exists everywhere. So for the straight line, we would say x is an element of real numbers. If we were talking about its domain, from left to right, function is existing everywhere. The arrow is extending this side, the arrow is extending that side, it's unrestricted. So from left to right, function exists everywhere. What about the range? From the bottom to the top. Once again, from the bottom to the top, function exists everywhere. That means y is an element of real numbers. As long as the function is unrestricted, we can say domain, x is an element of R. Range, y is an element of R for the straight line function. Okay. All right, let's move on. Let's move right along. The next question, guys. They are saying now, if h of x is equal to f of x plus 3. Now, my question to you guys is, we were talking about f of x and g of x. And all this time, we've been talking about f and g. And now we ask the range of g. Now, all of a sudden, they are saying if h of x. Aibo, where is this h of x coming from? Was the h of x mentioned above? No. So what is this h of x? Well, it is a new function. So we need to accept that we have a new member in the class. We have a new member in the class. Do you remember, guys, when like you were at school and then there was this new person that arrived in the class? How is that feeling when you have a new member in the class and that new member is just new? All right. But what do you notice after time? You actually realize that this new member, even though they are new, they are actually just human, just like you. So basically, h of x, how is it formed? You take f of x, as they say, which is this function, and you add 3. Meaning, what they've done is they've taken this function, and we know that if we are adding 3 to the entire function, there's something that happens to f of x when we add 3 to f of x. What happens? Can someone tell me in the comment section? If we add 3, remember, if we are saying this is f of x, and then all of a sudden I take 3 and I add it here, I'm adding it to which parameter? I'm adding it to q. When I add 3 to q, what am I actually doing to the function of f of x so that h of x is formed? Adding 3 to the value of q, which in this case is -1. What effect does it have on the function? Yes, Novuyo. Mwah. Novuyo. Very good. I'm so proud of you. It moves the function of h of x 3 units upwards. Yes, Oyama. Very good. It moves the function of f of x 3 units upwards. We call this vertical translation. The parameter of q affects the function in this way. It either moves the function if we add to it up, or it moves the function down if we were subtracting from it. That is the effect that q has on the function whenever we are either adding, meaning we move it up, we're moving the function up, or if we are subtracting, meaning we move the function down by however many units is there indicated in the actual equation. So very important, guys. I repeat again, yes, vertical shift and moving 3 units are very good in Mbalete. So h of x, what did I say to you guys? I said h of x is a new function. It's newly introduced. But now they are describing on the right-hand side how it was formed. Take f of x, add 3. What does that mean? Shifting the graph of f of x by 3 units up. So if we are shifting the graph of f of x, let's come here, guys. Let's think about this. If you are to shift the graph, this one, by 3 units upwards, what happens? The entire function, meaning the entire minimum value, the turning point moves, right? So we add 1. If we add 1 to -1, we get 0. This is where the function would start. This would be the minimum here. If you add another 1, you get 1. That's plus 2. If you add another 1, you get what? 2. So that means the function would start there at 2. This is where the turning point would be, guys. Do you understand this? Right? Let's look at it again. It says f of x plus 3, meaning they are taking this function, adding 3. So I'm saying it's like they are shifting this function. How many units? 3 units up. 1 unit, we are at 0. 2 units, we are at 1. 3 units, we are at 2. So the new turning point of the function that you had is not going to be that 0 and -1 that we had. It's going to be 0 because we are still on the y-axis. Remember, the x value on the y-axis is 0. And then the y-coordinate would be +2. So it would be 0 and 2. Remember, what did they say here? If h of x is equal to f of x plus 3, write down the coordinates of the turning point of who? Of h, the new function. So what are the coordinates of the turning point of h, the new function? They would be, guys, we just found them now. They are the coordinates. Remember, when you write coordinates, you have to write them in brackets. You write your x coordinate first, your y coordinate last. So what would be the coordinates? Thank you, Mbalele Mthetwa. 0 and 2, Oyama. Beautiful. I can sense that these people that are commenting in the comment section, they are really like, they are moving with me, like, you know, like nobody's business. Like at every turn, they are with me. Thank you. 0 and 2. Don't forget the brackets, Neoya. But I mean, I get your point. 0 and 2. So that's why they're just saying write down here. Okay, let's move on. Let's move on, guys. You get the point now? You get the point. What if they had said, if h of x is equal to f of x plus 3, what is the equation of h of x? Had they said to you, what is the equation of the function of f of x? Then what you would do, guys, is you would write down what they have, which is h of x is equal to f of x plus 3. Then you would say h of x. Now, you know most that f of x is represented by who? It's represented by x squared minus 1. So in the place of f of x, we are going to put who? X squared minus 1. So let's go and do that. X squared minus 1. We now have in the place of f of x, x squared minus 1. Then we add who? We add 3. Then what we would have? H of x is equal to, what's x squared? We have like terms here. What's minus 1 plus 3? We get x squared plus 2. So it makes sense that you and I, when we wrote down the the turning point of h, remember the turning point, what did we say? We said the turning point and the y-intercept in grade 10 for your parabola is the same. In grade 10. Why is it the same? Because your function is symmetrical in grade 10 for the parabola along the y-axis. The axis of symmetry is x is equal to 0. That's why. So your turning point, your y-intercept in grade 10 is the same, people. It's the same. Okay? So that's why if we want that turning point, obviously, if they had said determine, we would let x be equal to 0. Then say h of 0 is equal to 0 squared plus 2. Then we'd say 0 plus 2. And then obviously h of 0 would give me, what's 0 plus 2? It's 2. Therefore, meaning that the turning point when x is 0, y is 2. So it makes sense. You guys, we answered that previous question of finding the coordinates of the turning point by simply moving the function how many units up? 3 units, because we understand the meaning of addition to the function, what it means. It's moving the function. Plus 3 means moving the function up by 3 units. But if it was minus 3, we would know it was moving the function downwards by 3 units. Let's continue, guys. Number 4, determine the maximum value of P. The what? The maximum. Thank you, Miss Kathy, for the rose. Really appreciate it. First gift of the day, guys. It makes my heart to rumble. Thank you so much. Really appreciate it. Celebrating you with that clarion call. I really appreciate the rose. Miss Kathy, thank you so much. Determine the maximum value of P if P of x is equal to negative h of x. Now, guys, once again, P of x. Did we see P of x featuring anywhere in the previous questions? Or is P of x something we are seeing for the first time? Okay, so if P of x is featuring for the first time, what does that mean? It means we've got another new member of the family, people. Another new function. Yes, it's a new function, people. We've got a newborn baby. No, I'm just kidding. Okay, so determine the maximum value of P if P of x. How is P of x formed? By multiplying a negative with h of x. Wow. So P of x is Mr. New Function. We take a negative and we multiply the negative with h of x. What is the function or the equation of h of x? Well, thank goodness we were able to actually find the equation of h of x. There it is. That means we are going to replace x squared plus 2 in the place of h of x. X squared plus 2, guys, in what? In beautiful freaking brackets. In the place of what? In the place of the h of x. Remember, h of x entirely. Not in the place of x, oyamane. In the place of h of x, we are taking the entire x squared plus 2, because x squared plus 2 represents h of x entirely. So we replace that h of x that was there with the expression, which is a binomial, x squared plus 2, and we intentionally put brackets around, because if there's something outside, we best rest assured that we are going to be distributing, applying the distributive property of multiplication over addition. Yeah. Hey, guys, don't mess around with us. Distributive property of multiplication over addition. Hence, we're seeing negative having to be distributed to the first term and to the second term of the expression. So we get the function of p of x, which is what? Negative x squared minus 2. Now, these people, it's like they already told us that determine the maximum. Why would they think it's the maximum? Why wouldn't they say maybe the minimum? It is because, guys, what do we see here as the coefficient of the x squared term for px? What is the coefficient? A is less than 0, which means if we were to sketching the function, we would have a what, guys? A concave down. A concave down function has a what? A maximum. A maximum. That's why. So these people, when they asked the question, they asked knowing very well that our function p of x would have a value of a, which is less than 0. Concave down, meaning we have a what? A maximum. So the question now that they're asking is, what is our maximum value? Remember, guys, what did I say about the maximum value? I said that the q value, we would literally say maximum value is equal to negative 2. Simply put, because the maximum or the minimum is always the q value of the parabola. All right, so that is negative 2. The maximum value of p is negative 2. That's what it is, guys. That's what it is. And because the question said determine or determine, that's why we had to first go through this step so that they can see that, yeah, we know what we are doing. And determine suggests that you need to show steps of how you got there. So it would literally be important for you to first get the equation, then extract the value of the maximum from the function, which is basically the q value of the function p of x. Okay. Are we good? Are we together? Are we together? All right. Are we together? Are we together? Are we following? Follow. Kwaka, siviwe. Beautiful. Let's move on. Sketch the graphs of h and p on the same set of axes. Sketch the graphs of h and p on the same set of axes. Sketch the graph of h and p on the same set of axes. H, we have him. P, we have him. So let us just go ahead, you know what, and blindly go ahead and do what? Say h of x is equal to, there's the function, it's x squared plus 2. So we know that we can use the dual intercept method. So let's just blindly go ahead, guys, and use the dual intercept method. I mean, after all, what is there to lose, you know? Dual intercept method, we know we find y-intercept. There we let x be equal to 0, all right? We already know that the a value here is equal to 1, which is greater than 0. So what we're expecting is a concave up graph. So our shape, we're already expecting what we are going to get. We let x be equal to 0 to find the y-intercept. So we are going to say h of 0 is equal to 0 squared plus 2. 0 plus 2. We get 2. h of 0 is 2. The coordinates of the y-intercept are 0 because x is 0 and y, which is 2. So these are the coordinates of the y-intercept. Then we find the x-intercept, of course. It would only be right. Let y be equal to 0. We plug in the place of y, which is basically h of x entirely. We plug in 0 in the place of h of x. Then we say equal to x squared plus 2. We look at this and we're like, kind of hard to factorize, but you know what? Let's take the 2 over. We write the negative there. We get x squared isolated. We take the square root on both sides. We put plus minus because we're like, you know what? This should obviously work. The square root of x squared is x. We grab our calculator, we like, let's punch this in, square root of negative 2, bam! What do you guys get in your calculator when you put the square root of negative 2? What does the calculator say? 3, 2, 1. Punched it in, the square root of negative 2. Oyama, math error, big Q. Yes, undefined. Kwaka says undefined. Libongolet says undefined. Guys, it's a math error, which means non-real. In other words, there's no real solution. Okay, the math error in this situation speaks to that system of numbers that we call imaginary, non-real. Remember, guys, a negative number inside a even root is non-real. So in other words, what they are saying here is that there are no x-intercept. That's what it means for this situation. This graph that you are going to be sketching has no x-intercept. You could note that you cannot apply difference of two squares, Maple, Sarah, SA, because difference of two squares needs a difference in between the two terms. There's no difference here, so you can't apply that. You can't even say difference of two squares, because you can see here this is a sum. This is a perfect square, but 2 is not. So you can that is not even going to work here. There are no x-intercepts, no real solution. This math error for a negative number inside a square root means there are no x-intercepts. If there are no x-intercepts, guys, then it means our parabola does not cut through. The parabola doesn't cut the x-axis. And is it possible for some functions to not cut through the x-axis? Yes, it's possible, guys. So this is no train smash. Calm down, relax, breathe. Okay, it's only normal. It's only normal. All right. Now let's go and do that with the other function, because it was not only p of x that they wanted. They also wanted us to also do h of x. Now the function of not h of x, but p of x. We did h of x. Now we can do p of x, and we'll sketch shortly. P of x is equal to negative x squared minus 2. Negative x squared minus 2. So let's first establish our a value is negative 1, a less than 0, meaning it's a concave down function. Okay. Y-intercept, you can see what it is. If you let x be equal to 0, p of 0 is equal to negative 0 the whole squared minus 2. You have negative times 0, which is 0 minus 2, you get negative 2. So p of 0 is negative 2. The coordinates are 0 and negative 2. That's your y-intercept. So we have a y-intercept. What about an x-intercept? So y int, x int, we let y be equal to 0 for our x-intercept. In the place of p of x, we substitute 0 is equal to x squared, negative x squared minus 2. You transpose the negative 2. You get 2 is equal to x squared, negative x squared. You divide both sides by negative 1. You get x squared is equal to a negative 2. Take the square root on both sides, plus minus. Oh man, seems like we got the same situation. What do we have here? Once again, non-real, meaning no real solution, meaning no x-intercepts. Again, no x-intercepts, right? Now, let's try and make sense of this, because we were asked to sketch these functions in the same set of axes. Now, what do we do when we only have y-intercept? So for this function, which is concave up, 0 and 2. So let's just say 2 is here, all right? Because it's a concave up function, we are just going to have to use a bit of a table method here so that we can get an opportunity to check. Let's substitute -1 and 1. When you have a situation where there are no x-intercepts, take x is equal to -1. Come and substitute it into the function. -1, the whole thing squared is +1. 1 plus 2 is 3. So when x is -1 or when x is +1, our y value is 3. So it's this point here. It's that point there. You can do the same, guys, with 1. If you take 1, you substitute it in the place of x. 1 squared is 1 plus 2 is also 3. So what you find is that you can use these points to just kind of show where the function kind of sort of is. Then you can extend using sort of like, and then you can just have 1 and 3, -1 and 3. So do you see this thing that on the same horizontal line, that is y is equal to 3, these points are symmetrical along the what? The y-axis. And I said the equation of the y-axis, the axis of symmetry, is x is equal to 0. Symmetrical along the same horizontal line. The equation of this horizontal line would be y is equal to 3. The y value, look at the x value. This is -1, that is +1. That reveals symmetry, guys. Okay, so you see this function has no x-intercept, does not cut through the x-axis at all. It makes sense. That is why when we try to find the x-intercept, we got no real solution. So it happens, guys. It happens. It happens. Then let's go now and sketch the other function. 0 and -2. Okay, 0 and -2 down here somewhere. Okay, but what is the shape? It's concave down. So once again, we are going to come to our table. Take -1, go and substitute it into this function. Okay, if we take -1 inside the bracket, say -1, the whole thing squared. Remember, there's a negative on the outside. Okay, x, you substitute -1, but this -1 is outside. You square the -1 and then you say -2. What do you get? You get 1 once, and then that -2 gives you -3, right? So that -3 that you get, okay, -1 and 3, 1 and -3. So if you sketch turns there, you can just, you see, do you see that, guys? So you can say this point is 1 and -3. This one is -1 and -3. Okay, please, whenever there are no x-intercepts, please just use -1 and 1 so that at least you can see what's happening this side. Take your x value, go and substitute it back into the original function so that you can get your corresponding y value. Just so that you can get a picture of what's happening on this side and what's happening on this side. Then you extend it yourself. You draw an arrow to indicate. So now I can label this function and say p of x is equal to -x squared minus 2. And then this one is h of x is equal to x squared plus 2. Guys, isn't that just beautiful? You just sketch functions like that, and it wasn't even a pain, not a cinch. Can you please help with EGD if you can? Oh, unfortunately, I cannot. My beautiful, amazing guy who's there, or young lady, I can't help you with EGD. I am not EGD'd. Okay, I'm a maths junkie. Okay, those who know me know. All right, I'm a maths junkie, and hence maths is a game. Who in the world would do extra classes at 9:46 at night and call his channel Maths is a Game, unless they are a maths junkie? Okay, I'm a maths junkie, and I delight helping other maths junkies that want to do exceptionally well in mathematics. You see, when the red pen does these things, guys, beautiful, hey? Yeah? Isn't it nice when you go to your paper and you find that everything is just, you see, everything is like this. It's red, guys. It's red. And then you see this beautiful percentage and you're like, yeah, man, yeah. All right. Imagine 75 out of 75. Dream it to believe it, you know? Miss Kathy's like, it's really nice. Oh, yeah. Oh, yeah. Okay. All right. So we drew those in the same set of axes. Determine the y-intercept of the graph of y is equal to negative g of x. The y-intercept of the graph of y is equal to negative. Now, negative what? G of x. So the minus sign is being multiplied to g of x. What's g of x? X minus 1. We substitute in the place. Y is equal to negative g of x. So in other words, negative is the g of x. Here is g of x. It's x minus 1. So you substitute in the place of g of x in its entirety. You put in brackets the x minus 1. Then what do? You play the distributive law. So y is equal to negative x plus 1. There it is. Determine the what? The y-intercept. Now we have the opportunity to determine the y-intercept. When we want to find the y-intercept, what do? We let x be equal to 0. Guys, it's so nice, this thing. If you want the y-intercept, you let x be equal to 0. If you want the x-intercept, you let y be equal to 0. If you want the y-intercept, you let x be equal to 0. It's like if you want the y-int, you let x. If you want the x-int, you let y be 0. And then you just solve, guys. So you're just applying the algebra that you are basically, you've been applying all this time. Okay, put 0 in brackets. Negative is outside. Negative times 0 is 0. Plus 1 is 1. Therefore, determine the y-intercept. Okay, y is equal to 1. The coordinates, though, of the y-intercept are 0 and 1. Okay. Determine the x-intercept of the graph of y is equal to g of x plus 2. Look at this one. They are saying y is equal to g. Okay, so we are going to the function of g of x. But what are we doing? In the place of where the x is for this function, we are going to substitute what instead? The expression x plus 2. So let's go. Y is equal to g of x. Y is equal to g of x plus 2 in brackets. When the x plus 2 is in brackets, guys, it means that is replacing x. We replace x for function g of x. Does that make sense? We replace the x for the function of g of x. So in the place of where x was, we are going to replace that with x plus 2. So g of x plus 2 is equal to, in the place of x, we are going to write x plus 2 minus 1. Okay, you see? Then that means we remove the bracket x plus 2 minus 1. That is x plus 1. Okay. So that's g of x plus 2. But what do they want? The x-intercept. So if they want the x-intercept, we let what? We let y be equal to 0. So in the place of all of this, 0 is equal to x plus 1. We transpose x is equal to negative 1. The coordinates are what? Negative 1 and 0. Okay. Hi guys. It's not Nginga at all. It's not Nginga at all. All right. Yeah. Okay. Let us move to this activity. I'm gonna return back to the other one. I just wanna move from that one to this one first, and then we can always return back to the one that I just kind of surreptitiously skipped. Anonymous, thank you so much for the 5 amazing roses. Thank you so much, Anonymous. Thank you, Anonymous, for the 5 roses. Really appreciate you, sir. Or is it ma'am? Anonymous is anonymous, eh? You can even see by that profile picture. It's one of those trump card profile pictures. And yeah, I think like, yeah. The graphs of f of x. Let's look at this, guys. The graphs of f of x. Can we just analyze this question a little bit here? The graphs of f of x is equal to mx plus c. So f here is f. This f is a straight line. You can see there's the f, so that means it's a straight line. If you were to talk about the gradient of f, let's just talk about it. What are you expecting will be the gradient of f? Will it be positive or negative? Just in the comment section, guys, if you can just let me know. What are you expecting the gradient of this line to be? Positive or negative? Based on the direction of the line. Thank you, Sfundo, Big Q, T, Yolanda, Muffin, you Muffin, Libongo Letole Bongo. Yes, sir. Seville, yes. Oyama, beautiful. I like how Oyama is like an outlier and she just like puts a negative sign instead of actually writing out negative. Talk about saving space or saving energy, you know, preserving energy, so that you just type the symbol. Okay, very good. You all are right, guys. We're expecting a negative because the direction of the straight line is a decreasing straight line. It's sloping downward. Thank you very much. Mx plus c. Can I ask you guys, since you understand what c is, what value are you expecting the c value to be, positive or negative, based on the straight line and how you are seeing it? The c value, are you expecting it to be positive or negative? Let's see if you guys get that one. Big Q says positive. What do the rest of the babies in the comment section say? Muffin says minus. Viewer says positive. Oh no, It seems like people are really taking their time to think here. Oyama says positive. Young T says negative. Lipongoleto says negative. Okay, guys, what does C stand for? C stands for the y-intercept. If you look at this straight line, where is it cutting the y-axis? Is it cutting the y-axis for your y values that are positive, or is it cutting your y-axis for your y values that are negative? Because your y values here, how are they, guys? Your y values that are above the x-axis, how are your y values here? Thank you, Sihle. They are positive, guys. Guys, your y values here are positive. The straight line is cutting your y-axis where y is positive. So what are you expecting the y value of the y-intercept for the value of c for the straight line to be? Are you expecting it to be positive or negative? This is a very important thing to note when you are looking at a function. What are you expecting the c value to be like based on the sketch? So I'm looking at the sketch and I'm looking at this point and I'm like thinking, where is this straight line cutting the y-axis? Is it cutting it where y is positive, or is it cutting it where y is negative? So you guys can see that it's cutting the y-axis where y is positive. So our c value should also be positive then. Okay, so guys, you can look at the function and project, anticipate what the signs of your m and your c will be, so that when you do your calculations, you do them with a knowledge of what is to come. Because if you're doing this just for the sake of doing it, guys, but you don't have a sense of knowing what is to come, then I think personally functions are not playing their role in educating you about the Cartesian plane enough. Okay, so please, guys, just that logical common sense can save you, because when you do the calculations, what you want to do is to be able to confirm for yourself the answers that you get. You see? Okay, let's go to g of x. Now I'm going to ask you again the same questions. Look at g of x. Look at the coefficient of x squared, the a. Based on the shape of the function, are you expecting a to be positive or negative? Comment, guys, in the comment section. Based on the shape of the parabola, what are you expecting the a value to be like? Positive or negative? Big Q there, always getting us started. It's not Hando. Sihle, Ziko, libongoleto, leto kuhle, kwaka. Very good, guys, all of you. All of you are amazing people. My heart beats for you. My hands clap for you. I want to cheer for all of you. No, she's chubby. When you just want to throw a spanner in the works. She's chubby. You even have a nice photo of a nice phone there on your profile picture, but now you are, hey, she's chubby. A, guys, denotes the shape of the function. Remember, if it's concave up, then A is positive. All right? Please, guys. She's chubby. Let's get our act together. The B represents what? And therefore, if it represents what it represents, what are you expecting the B value to be like? Positive or negative? Let's check. B represents something. Seeing where the position of that thing is, what are you expecting the B value to be like? GP Makubela, thank you so much for the comment. Thank you, She's Chubby, for the comment. Viewer, thank you for the comment. Big Q, Appeller, Yolanda, Quaka. Yeah. Okay, guys, very good. Very good. Very good. So because here we are speaking about the y-intercept being on the negative side of the y-axis, we are expecting that y-intercept to be a negative value y. So our B, we already anticipate these things. So do you see, guys, the beauty of doing this thing? You are just analyzing the sketch, nothing more, nothing less. And then you are looking at where your y values are for your y-axis and then determining. Also understanding what you know about the gradient of a straight line, understanding what you know about the coefficient of x squared for a parabola, you can also expect what kind of value of a and m you should have. Now look, let's read now. The graphs of f of x and g of x intersect at where? At D. We are told that these two functions, they do what? They intersect. What does the word intersect mean? Intersect. They intersect at D. Yes, She's Chubby. They meet. Don't we all like meeting, hey? We like meeting. Some of us even like eating meat whilst we meet. You know, we eat meat whilst we meet. Yeah. So intersect at D, meaning this here is what we call where the two functions, they meet and they eat meat. It's called the point of intersection. This point. They intersect at D and on the x-axis at A. So D is a point of meeting. A as well is the point of meeting. Very good, She's Chubby. She's Chubby. Look at the comment that She's Chubby has said in the comment section. So they're gonna have the same coordinates. Very good. Yeah, where we meet, we discuss the same ideas. I mean, we discuss same things, you know. If we are going to meet and eat, we are going to meet and eat the same thing. Yeah, going to have the same coordinates. So A and D represents points for the two functions where they have the same what? The same coordinates. Very good, She's Chubby. Very good observation. You see, now She's Chubby, you are starting to comment in a very nice way, you know, with understanding and also with contribution. So they intersected D and on the x-axis at A. So the point A is not just a point of meeting for the two functions. It's also a point of meeting where the x-axis also meets with these two what? With these two functions. Remember, here on the x-axis, what is the equation of the x-axis? Let me just ask again. What is the equation? If I was to ask what is the equation of this horizontal x-axis, what is the equation of the x-axis, guys? I want the equation. She's Chubby, y equal to 0. She's Chubby is saying y equal to 0. Big Q is saying y is equal to 0. Okay. Thank you. Very good. Y is equal to 0. Very, very important. Okay, let's continue. Now they are saying H and T lie on F. H and T lie on F. When points lie on F, it means they exist there at the function F. And that's very important too. Now they are saying determine the equation of F. Very good, she's chubby. You see now they are saying determine the equation of F. And she's chubby just said a beautiful comment because of what we said about H and T. If H and T lie on F, then according to what she's chubby is commenting in the comment section, we can find the what? The gradient. The gradient of who? Whose gradient can we find? Yes, BQ, according to your according to analytical geometry, we can say that point H and T are collinear. Big Q is even adding another concept. This line out of kids. You guys, next level kids, this one. All right, so yes, H and T lie on this line, and they are collinear. You guys are speaking big things. You can find the gradient. All right, so guys, the equation of F, we want the equation of F. So to find the equation of F, there are two things we need. We need the gradient, we need the y-intercept. And it seems like according to she's chubby, the gradient is already sorted. We can find it. So let's go ahead and find the gradient. The coordinates of H we know are -1 and 4. The coordinates of T we know they are 4 and -1. Okay. Gradient of HT. Okay. Gradient of HT. GP Makubela. Thank you so much, GP Makubela. You are very kind words there that are commented. GP Makubela, you are very kind, very kind. So the gradient of HT there, guys. Gradient of HT, let's go. The gradient of HT is equal to y of H minus y of T, x of H minus x of T. I know some of you use x2 minus x1, y2 minus y1, x2 minus x1. As long as we have a change of y at the top and a change of x, and it's in order. If you start with H, you end with T. You start with H, you end with T. If you start with T, you end with H. Start with T, you end with H. If you use x1, y1, if you use y2 minus y1, x2 minus x1, make sure you label your points accordingly. It's the same thing, guys. All of this is the same thing. So y coordinate of H, that's 4. The minus sign is already in the formula. Y coordinate of T, -1. Then x coordinate of H, -1. Minus, there's a minus sign already in the formula, 4. So that means 4 plus 1. Negative times the negative is positive. -1 minus 4, -1 minus 4. That gives us 5 over -5, which is -1. Expected that the gradient be negative. I'm not surprised. I'm not shocked. If it would have happened that I make some error there and I get a positive answer, I would know that something is wrong. Why? Because when I analyzed the two graphs, I was expecting to get a what? A value of the gradient that is negative. You see, guys, how important it is to first analyze the statement? Because when you do and you then attach meaning to the function itself, then it makes things become sensible. You see, then the sense in what you are doing, you also can see, like, do you know how much of a confidence booster it is, guys, when you actually analyze something? You then read the function, you do calculations, and then it literally just fulfills what you were expecting. It's like it's a prophecy being fulfilled. All right. So the gradient of HT is -1, and I know for a fact it's true because I was expecting a negative gradient. And I've done my substitution correctly and I've written down the right coordinates. So I check as I write that I'm writing the right things. H, -1 and 4, yes it is. T, 4 and -1, yes it is. Y coordinate of h, did I already substitute 4? Yes, I did. There's a negative sign in the formula. Yes, there is. Y coordinate of t is negative on its own, so there must be negative, negative, which gives me a positive. That's fine. X coordinate of h, that's negative 1. There it is. Minus sign already in the formula. X coordinate of t, yes, it's 4. Minus 1 minus 4 gives me negative 5. Positive divided by negative, negative. 5 divided by 5, 1. Guys, I can't get there. So we are very close. Y is equal to negative x plus c. The only thing that's missing is the c value. So we take any point. Take any, h or t. It's up to you. Let's say I take t for a negative 1, and I'm going to substitute it where? In the function. So my x is 4, my y is negative 1. Very good, flavorful sand. You can use any, doesn't matter. All right, you will get the c value. Why do we substitute a point? It's because we want to solve for the c value. Remember, in our function, they did not give us a y-intercept. So therefore, it means we need to find it. After finding the gradient, we substitute the point or any of the 2 points and solve for c. And solve for c. All right, makes sense, guys? That's just patting myself on the back, guys. I need to just, encourage myself. So y is 1 equal to negative. There's a negative sign for the coefficient. X you substitute in brackets 4 plus c. Then negative times 4, negative 4 is equal to 1. We transpose the negative 4 over. When we take a number over to the other side, please guys, let's not forget that it changes the sign. So that's 4 plus 1, which is 5. Let's check. Am I expecting a positive c value for the straight line? Yes, I am. But there's a bit of a problem. Why is the c value seemingly bigger than, because if this is the c value, it's 5. Something is not giving. You see what I mean, guys? Or was there an error that I made? You see the h, it's here, right? The y value is 4. But to have a value of 5 here, below, it doesn't make sense, guys. Right? Makes no sense at all. Okay. It's the signs for the coordinate. What did I do? Negative 1 and 4. Negative 1 and 4 is that side. 4 and negative 1 is that side. 4 and negative 1. Check the signs maybe. Yeah, let's check the signs just quickly. So h, we did say, is negative 1 and 4. T is 4 and negative 1. So very quickly, yeah, go check my equation. I'm in varsity. Maybe it's not up to scale. Yeah, she's chubby. Yeah, it should be less than 4, but positive. That's the logical sense that's made here. It should be less than 4. So let's just check again, guys. I appreciate you guys' presence here. Y is equal to negative. Obviously, the negative for the negative 1. There's no doubt about that one. Y coordinate of h is 4 minus 1. So that's 5. No doubt. X coordinate of h, that's negative 1. We substituted correctly there. Negative 1. Oh, in the substituting I wrote 1, did I? Oh, I did! Thank you, Nido. Tandile. Thank you so much. Look at that. Big time error. Look, and you know why? It's because I put a y here to the x and the y, and then what happened is that I actually ended up negating my own negative sign. Do you see why? I ended up not seeing my own negative sign because I put that y there. Okay, do you see how sometimes we can shoot ourselves in the foot? Okay, thank you so much, guys. That was really helpful. Tandile Samka, thank you so much. Nito. Thank you so much, guys. That was really helpful. So, but do you see, guys, how knowing? Do you see that? Do you see how knowing what I see on my Cartesian plane helped me to see? Because my common sense could not really allow the value I got. Doesn't make sense that C would be 5, whereas I have a point H which is above, slightly above its corresponding y values for. It wouldn't make sense that I have 5 here. No. So that is why I ended up having to stop here and having to check. I'm sure if I was alone in a test, I would have ended up checking the whole thing and I would have traced my personal mistake that I made. And then it would have led to me actually changing that and then getting the answer. But I'm grateful for people like amazing Nido and Tandila Samga, who are just amazing people. C is equal to 3. They spot errors like, so C is equal to 3. Then the function, therefore, is what? F of x, because remember we were given the function as f of x. Guys, you always go back to writing the function, the equation. They want the equation of f, and it's already given as f of x equal to mx plus c. Please, you don't write y is equal to, no. You finish off by saying f of x is equal to negative x plus 3. The m value makes perfect sense. The C value makes logical sense. I'm not just doing calculations for the sake of doing calculations, but I'm aware of what that value means in light of what I have around it. Does that make sense, guys? And that's why, for instance, that C value was worth checking, because common sense says you can't have a value of C bigger than the point that is above it. It makes no sense. So that's why we had to check it. Okay, thank you so much, guys. Yo, that was power. That I feel like drove a power lesson, which is fine. Now, number 2, the coordinates of who, guys? Of A and C. Oh my goodness, I almost feel like we're gonna be voting for A and C here. What is this? The coordinates of A and hence C. She's chubby. Look at she's chubby. So she's chubby says A and C are gonna have the same values but different signs because they are the x-intercept of a what? Of a parabola. Can we just clap for that? She's chubby. Now she's chubby initially made this big error, right? But like she's since been making up for it like insanely, right? Just like saying all these big amazing things there. So I'm proud of you there, making that sweet comeback. Not allowing like your first error to kind of like make you feel despondent in my life. Very good. I love it. So yes, guys, she's chubby is 100% correct. A, where's A? These are the things we need to do. If they say find the coordinates of A, let's first locate this A. Where is it? It's here. What did they say about A? A is on the x-axis. And what else do we know? It's the point of intersection of the two functions, but also it is the x-intercept for the parabola and the straight line. So what can we then do, guys? Because we don't have the equation of the parabola yet, but we have the equation of the straight line. We just found it. We just found the equation of the straight line, guys. So we don't have the equation of the parabola yet. We can't use that, but we have the equation of the straight line. So to find A, we can go ahead and do what? Find the x-intercept of the straight line. Okay, we work with what we have and what we can actually do with what we have. So g of x, that's what Flavorful sent, 100%. The x-intercepts of g of x, very good, because we have the function of g of x. So let's go there. X-intercept of g of x, as Flavorful sent says. So we let who, when we want to find the x-intercept, we let y be equal to 0. G of x is equal to negative x. Oh, sorry, not G, F. It is F, guys, sorry. We find the x-intercept of f because f is the straight line, the equation that we do have. Yeah, we can use the straight line. Thank you, Young T. We can use the straight line. I also just realized that it is the straight line. For some reason, I thought the straight line is G. Now I realize, no. The straight line is actually f, which is the equation we just found. So we are going to let y be equal to 0, which means we are going to replace the entire f. Let's just rewrite this so that it's neater. We are going to replace the entire f of x with 0. We take Nando's. Hello. My goodness, Nando's. My life goal, my guy. Take the 3 over. Negative 3 is equal to negative x. Then we divide both sides. We divide both sides by what, guys? Coefficient of x, negative 1. Then we get what? X is equal to 3. So that means the coordinates, yes, she's chubby, very good, 3 and 0. Does it make sense? If you look at A, where it is, you look at point T, which is 4 and negative 1, which is here. But on this vertical line, the x values are going to be the same throughout this vertical line. So it makes sense that that point is 3. Makes perfect sense in light of what we have. So A is 3 and 0. Then I suppose we can use the logic that Shiz Chubby said. If A is 3 and 0, C is negative 3 and 0. Because Shiz Chubby said something about the fact that if we know that these are the x-intercepts of the parabola, because of symmetry. Guys, I'm repeating this thing. Thank you, Anonymous, for the roses, my bra. Thank you. I'm going to celebrate after. Just want to clarify, finish this point. Because we know this is the axis of symmetry. Okay, that means these values of A and C for the x value are going to be the same, but the signs are going to be different, because we say A and C are actually reflection. A is a reflection of C along the y-axis, just like C is a reflection of A along the y-axis. When we reflect along the y-axis, guys, it is x that changes whilst y stays the same. The sign of x changes, but y stays the same. So it's very important that we understand that on the same horizontal line, these points, basically, the distance from O to A will be the same distance from O to C. So even with the distance, guys, OA and OC have the same distance. OA from 0 to 3, we would say the distance here of OA is 3 units. From O to C, we would say the distance is 3 units. And from C to A, obviously, that's the addition of the two distances, which would be 6 units. So that is just other things to understand just from what we are gauging from here. But yes, coordinates of A, 3 and 0. Coordinates of C, negative 3 and 0. Let's move on to number 3 now. The equation of G. The what? The equation of G. G is the parabola. To get the equation, we need A and we need B. We are not sure the y-axis cuts through the turning point. Like Makucha, we are 100% sure that the y-axis cuts through the turning point because the form of our function g of x is equal to ax squared plus b. This type of function here for the parabola 100% passes through the turning point, which is the y-intercept. In grade 10, if you are not in grade 10, I would understand why you are saying what you are saying, because you are probably in 11 or 12, or you are finished with school, and you've probably forgotten that in grade 10, there is an imposed restriction in the parabola that Greek tends to, in that it is always symmetrical along the y-axis, which means that the turning point and the y-intercept coincide. All right, they coincide. So this form represents such. Anyways, I hope that's clear for us, guys. The y-axis, the line x is equal to 0, is the axis of symmetry, which is therefore having the y-intercept and the turning point. Okay, coordinates, the equation of G. My man, are you a teacher? What do you think? Judge for yourself. Judge for yourself. Judge for yourself. Those who know me know. You must know as well. All right. Let's take this moment and just celebrate my man Anonymous for the 2 amazing roses and the 3 amazing roses in succession in this live lesson, supporting me very nicely. Thank you so much. Really appreciate it, buddy boy. You'll be blessed for supporting my life goal there. I really appreciate you, man. Okay. Now, guys, the equation of G, I need to let you guys know that when you want to find the equation, and let's say you are given the x-intercepts and the one other point, then like GP Makubela has said, we can use the form, the x-intercept form, which is y is equal to a into x minus x1 into x minus x2. But let me say, guys, if let's say we had been given the y-intercept, then there would be no need to use this form. Because if we have the y-intercept, it's a matter of going ahead and substituting the b value, which is the y coordinate of the y-intercept. Okay, and then you would basically choose another point, substitute it, and solve for a. And that makes life very easy if you had the y-intercept. But here in this graph, we have the x-intercepts. We just found them. A was 3 and 0. C was negative 3 and 0. And then G is another point that the function passes through, or the point G lies on the function. So if we have one other point and the x-intercept, this here, the y is equal to a into x minus x1 into x minus x2 is used when you have your 2 x-intercepts and one other point. Very useful. Very, very useful. Remember, we found the coordinates of a and c. Remember, we used the function of f of x. We found the x-intercept of f of x because the x-intercept of f of x also touched a. All right? Also touched or passed through a. So we used the what? The x-intercept. We let who? We let y be equal to 0. Okay? We let y be equal to 0. And then what did we get? We got x is equal to 3 for the coordinate, for the x-coordinate of a, whilst y is 0. Then c, we also got. C is negative 3 and 0. C is negative 3 and 0. So this is C, negative 3 and 0. This is A, 3 and 0. And then G, we are told, is a point that lies on the parabola. So these are the coordinates. G, 1 and 8, that's your one other point. A and C, which are your 2 x-intercepts. So if we have 2 x-intercepts and one other point, I said we can use this here to find the equation of the function. Sorry guys, just there was something I was attending to. Okay, so yeah, so x-intercepts, guys, one other point. So we can go ahead and find the equation then, all right, of this parabola. How? Y is equal to, we are going to hold on and just substitute the x-intercepts. So -3 is going to be our x1. +3 is going to be our x2. So we're going to say x minus, but then -3 is negative as well. So we say x minus -3 into x minus, x2 is positive. So we say x minus 3, because the positive times the negative still gives us a negative. Then G is a point. X is going to be 1. So we are going to substitute G, which is 1 and 8. Why do we do that? Why are we going to substitute 1 and -8? Sorry. We're going to substitute 1 and -8 so that we can get an opportunity to solve for A. All right. So y is equal to A into x plus 3 into x minus 3. And negative times a negative gives you a +3. Have y there. X is 1. Y is -8. So we say -8 is equal to A into, in the place of x, 1 plus 3, 1 minus 3. If you see, guys, we're substituting in the place of x the 1, just the 1. In the place of x, we substitute just the 1. 1 plus 3, 1 minus 3. A into what's 1 plus 3 is 4. 1 minus 3 is -2. That's -8. We multiply all of this. We get -8A. We get -8 on the other side. You divide both sides by the coefficient of the A value, which is -8. But what you do on one side, you do on the other. So that means A is going to be +1. Does A being +1 make sense? Does A being +1 make sense? If you look at the shape of the graph. You see, and that is one of the things that you just check, because you know what you know about A. Okay? Yeah, it's a smile face. Thank you so much. It is. So it makes sense. So if A is +1, it makes perfect sense, which means my substitution and also my algebraic skills have been applied well to get me here. Because a silly mistake, you know, do you see, guys, I nearly once again wrote a positive coordinate here, not writing the coordinate that was represented there. It seems like I have a problem with signs. I have a tendency of forgetting the signs when I'm writing them down, and that is going to be costing me personally. So if you are like me, please make sure that you don't be like me when you write. Okay, so A is equal to 1. So we go back to this stage and we go and substitute the A is equal to 1 back here. Y is equal to, you take the 1 you substituted here, 1 into x plus 3 into x minus 3. You see, because you left, you substituted 1 and -8 because there was nothing more you could do here at this function. The only thing that was missing now was what? The A value. You got the A value. Now you need to take it back where you left the A, still wanting to know why it is. Okay, so we can go and substitute. Okay, substitute that A value there. So we go y is equal to x plus 3 into x minus 3 is the reverse of a difference of 2 squared. So I know this is going to lead to x squared minus 9. The 1 outside, you distribute. You get x squared minus 9. This is the function of g of x. Ax squared plus b. They said ax squared plus b. But now we know that the actual value of A, if they had said find the value of A, we could say A is equal to 1, B is equal to -9. We got them, guys. A is 1, B is -9. But this is the equation. They wanted the equation of G. We got them the equation of G. We have it with us. They wanted it. We got it. We got it. We got it, people. We got it, guys. Okay. So please, guys, this method is used if you have 2 x-intercepts and 1 other point. Okay. 2 x-intercepts and 1 other point. Please, guys. Please. 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 Okay. All right. Yeah. Okay. Please, please, please. Please, please, please. All right. All right. Yeah. No, Makubela, look. The g of x was given as ax squared plus b. All right. The small letter b. I'm talking about this here. B is -9. A is 1. I'm talking about for the function. Had they asked for a and b in the equation, we would have said a is equal to 1 and b is equal to -9. This is what I'm talking about. I'm talking about that. Okay. All right. They can use any alphabet. Very true. She's chubby. Okay. Yes. C may be what you guys are used to, or Q, but it does not mean that Q and C. Okay. Sorry, I thought you were on a general quadratic equation. No. Kaloku GP Makobela, the general quadratic function in grade 10 is not ax squared plus bx plus c. The general quadratic equation is ax squared plus b for this particular function. Remember, b, what you need to primarily understand is that that constant stands for the y-intercept. The coefficient of x squared stands for the shape of the function, you know, and the obviously relates to other things. Okay, let's move on, guys. The length of AC. Now we want the length. Guys, let's look at these length questions. Length questions are very important. Length questions, okay? Length. The length of AC. Now, where is AC? They want AC and OB. Where's AC? Here is A, here is C. A is on the right, C is on the left. Okay? They want you to determine the length of AC. They don't want you to write down the length of AC. They want you to determine the length of AC. Okay? So that's where I know most of you, you know distance formula, all right? From basically analytical geometry. But now you need to understand that when they say AC, they are talking about a horizontal length from left to right. For a horizontal length, guys, okay, AC, we are going to say x on the right minus x on the left. And rest assured, here in this case, my x on the left is my A. The x on the right is A, x on the left is C. This is right, this is left. So x on the right, we are going to say the x coordinate of A minus the x coordinate of C. So guys, my x coordinate of A, we know most x coordinate of A. What is the x coordinate of A, guys? Because it's a horizontal line. Okay, please, guys, don't remember, you could use the distance formula, but for a horizontal line, it's fine to use x on the right minus x on the left. So x on the right, the x value of A is 3. Very good. Okay, then minus x, the x coordinate of C. What's x on the left? So that was 3. But what was the x value of C? Thank you, she's chubby. It's minus 3. Yes, Lucky. So it's -3, right? So x on the left is -3. So remember, the formula already has a negative sign, but then x coordinate of C is going to be -3. So we have minus 3. We know most that a negative times a negative gives us a positive, so it's 3 plus 3, which gives us 6. But 6 what, guys? Very good. 6 units. So we say AC is 6 units. Ne? All right. So this is straightforward. We can use, so for a horizontal, and this is only applicable, you can use this approach only for a horizontal line. You can't use it, guys, for a line that is like this, right? A line that has a positive or a negative gradient. You can't use x right minus x left. For these kinds of lines, you have to use distance formula. You have no choice, all right? But for a horizontal line, you can say x right minus x left, as well as the distance formula if you want. But this is pretty straightforward. Let's go. Now they want the distance of OB. Where's OB? Here's O, here's B. Okay. Now this is a vertical line. So different from a horizontal line, when we are calculating the distance for a vertical line, yes, she's chubby, we are going to say y at the top minus y at the bottom. Whose y that is at the top? What is the y coordinate of O here? What is the y value of O here? Okay, she's chubby is saying is 0. Is she's chubby correct, guys? The y coordinate of O, are we sure it's 0? Nito is saying 0 as well. Flavorful Sand is saying 0 as well. The y coordinate of O, is it 0 for real? Okay. Seems like these three are very confident. She's chubby, Flavorful Sand, and Nito are saying it's 0. Okay. So YO minus YB, because that's y at the bottom. Okay. What's the y coordinate of B again? Yes, Makubela, very good. At 0, 0, we have the coordinates. At O, we have, which is the origin. Very good, Manzama. It is. You guys are 100% correct. The origin O has the coordinate 0, 0. So the y coordinate is 0. You guys are 100% correct. I agree. Then what was the y coordinate of B? Do we remember, guys, what the y coordinate of B? What did we end up finding was the y-intercept, or the y coordinate of the turning point for the parabola at this point? Do you remember? We said it's -9. Remember, the equation was y is equal to x squared minus 9. So the y-intercept here is -9. So we have 0 minus -9. Okay, which is 0 plus 9, which is 9 units. Okay, vertical line, we use y top minus y bottom. Horizontal line, x right minus x left. Okay, guys, are we good? Okay, so horizontal line, x right minus x left. Vertical line, y top minus y bottom. Okay, yeah. But if it is in any other direction, like increasing line, decreasing line, then distance formula, we have no other choice. But these ones, horizontal line, x right minus x left. Vertical line, y top minus y bottom. Remember, there's already a negative sign for your formula. So when you substitute a negative number after the negative sign, always take that into consideration. Don't make errors. Okay. Let's move on. The length of DE. The length of who? Of DE. Where's DE? Here is DE. They want the length of DE. Now, what's very, very interesting is that we don't have any coordinates at the moment. Not for D, we don't have anything. There was nothing that we calculated that led us to the coordinates of D. Not for F and not for E. So there's one way to actually find the what? The length of DE. We need to first find the coordinates of D. All right. Can I ask this question though? What is the y value? What is the y value of the coordinate of E? Do you guys know what the y value of the coordinate of E is? The y value of the coordinate of E. Very good, guys. The y value of the coordinate of E is 0. All right. Very good. So if we had the y here at the top, we would say y top minus y bottom and get the length, the vertical length. Okay. So anyways, that's fine. All right. Now, to find the coordinates of D, we are going to have to take the parabola and the straight line and equate those two functions. Why? Because remember they said f of x and g of x intersect at D. So D is called the what? The point of intersection. So we can take f of x. Thank you so much, Junior, for the rose. Really appreciate you, buddy. We can take f of x and we can take g of x and we can make those two functions equal. Solve them simultaneously if you want to call that. Or we can just use the concept of point of intersection. Point of intersection. Point of intersection, that is where two functions meet and eat. So we will say f of x is equal to g of x. Okay. Yeah. F of x is equal to g of x. So let's solve for x, guys. Why are we interested in solving for x? If you look at what Shiz Chabi is saying, Shiz Chabi is saying D and E will have the same x value. That's very true, right? D and E are on the same vertical line, and any vertical line will have the same x values everywhere, right, on that vertical line. So f of x is equal to g of x. What is f of x? Remember, f of x was given by negative x plus 3. G of x was given by x squared minus 9. I think we can solve these two equations. We equate them, we solve. So x squared, let's take the negative x over plus x minus 9, take the 3 over minus 3, 0. X squared plus x minus 12 is equal to 0. This is a quadratic equation. So now we can solve the quadratic equation using our method. So this is in standard form at the moment. So it means now we have to factorize. So we open two brackets because this is a trinomial. A trinomial that has a negative constant. Negative constant means we are going to have different signs. But the highest factor is going to have a positive sign. Highest factor of 12 is going to have a positive sign. So we have 12 and 1, 6 and 2, 4 and 3. Which one works? 4 and 3. So it can't be negative 4. It's plus 4 minus 3 when we factor. X and x, okay? Y4, positive 4 minus 3 gives us positive 1. And then the multiplication gives you negative 12. The addition gives you positive 1. It can't be negative 4 and 3 months up. Can't be. It's 4 and negative 3. Here's another thing, guys. The constant, when it is negative, that means we are going to have different signs inside the bracket. But the sign of the middle term tells us the factor that is the biggest will have the sign of the middle term. Okay. So now we can get solutions. X plus 4 is equal to 0. X minus 3 is equal to 0. So x is equal to negative 4, or x is equal to 3. Thank you, Flavorful Scent. The biggest number takes the sign of the middle term. You're 100% correct. Okay. So D, based on these two values, D will have negative 4 as its what? As its x value. All right. Okay. Now we need the y value. So what do? We go and substitute x is equal to negative 4 into any of the two functions, either f of x or g of x, doesn't matter which one. So I'm going to substitute into f of x, negative 4. When I do so, f of negative 4 is equal to negative into negative 4 plus 3. That gives us 4, positive 4 plus 3, which is 7. Okay. So f of negative 4 gives you 7. So that means we have negative 4 and 7. So now when I want to calculate dE, I'm like y at the top, which is d, minus y at the top, which is e. The y coordinate of d is 7. Y coordinate of e is 0. 7 minus 0 is 7 units. It's as simple as that, guys. Okay, 7 units. So let's look at this one more time. What did we do here? We looked at d. The length of d, we do not have anything. We don't have the coordinates of d. We don't have the coordinates of f, coordinates of e. We only know that the y coordinate of e is 0. So at least we have y at the bottom. But it's just that we don't know what y at the top is. So what did we then observe? That point we were told is where f and g intersect. So what do we know about that point? It is called the point of intersection. What can we do with a point of intersection? Well, since there are two functions meeting there, we can make them equal. If two functions meet, we make them equal. Okay. And then we go ahead and we go ahead and we solve the equation. Get the equation in standard form, factorize, get the values of x. Obviously, look at the one that is relevant for the situation. D is on the negative side of the values of x. You know, the x value this side is negative. That's why we chose x is equal to negative 4, but we did not take x is equal to 3, because that x is equal to 3 represents the other point where the two functions intersect, which is 3 there. Okay, so that's why we took x is equal to negative 4, because we saw where d is actually situated as per your function. Okay, guys, I hope it makes sense there. Once you have your x value, you can take it, substitute it where? Into any of the two functions. Doesn't matter. I substituted it into the straight line, but I could have, if I wanted to, look, I could also substitute it if I wanted to into the parabola. Okay, which means 16 minus 9, which is 7. Same thing, you see, f of negative 4 is 7, which means the coordinates would have still been negative 4 and 7 had I used this function. So it don't matter. Then, okay, of course, you now have the coordinates of who? Of d. And you can go ahead, since you know that e is negative 4 and 0. Actually, now it's your x values, they are the same, but the y values obviously. Okay, for d the y coordinate is 7, for e the y coordinate is 0, but our x values are definitely the same. All right, so you could say y at the top minus y at the bottom, you get 7 units, and that's beautiful. DE, we have got him. Now DF, where's DF? DF, they want the distance of DF. So what do we need? Okay, the x value of E. Use the x value of E or D. All right, yeah, so that's, if it's a horizontal length, that means x on the right minus x on the left would work. So what is the x coordinate here at F? Because we want the length of DF. What's the x coordinate of F? Yes, guys, the x coordinate, remember here on the y-axis, The x value here everywhere is actually going to be what? 0. The x coordinate, guys, of f. This is very important. Okay, because if I want the length of df, it's a horizontal length. Remember, what did I say about the horizontal line? X right minus x left. So we need x on the right, which is the x coordinate of f. So I want fd, which means I'm going to take my x coordinate of f, which is x on the right, minus x on the left, which is x of d. What is x coordinate of f? 0, minus x coordinate of d. Now x coordinate of d, just to check again, is -4. So we say 0 minus minus 4. That is 0 plus 4, which is 4 beautiful units. Just like that. Okay. fd is equal to xf minus xd. 0, which is x of f, minus xd, which is -4. The negative times the negative is a positive. 0 plus 4 is 4 units. Sim dollar, what are you saying? Sim dollar, you probably just joined, didn't you? Because you're saying, what are you saying? Which means you are literally joining and you are saying, what are you saying? What are you saying? Let me ask you the same. What are you saying? Okay. What are you saying? Okay. 6. The length of ST. The length of ST. So once again, we look at S, we look at T. So if you're looking at S and you look at T, we have the coordinates of T. We don't have the coordinates of S. But because S and T, since this is a perpendicular line, since S and T are on the same vertical line, what is the same for your vertical lines? What is the same for our vertical line? Is it X or Y? Who is the same along the vertical line? X is the same. Thank you, Soleto. X is the same. So that means if here the X value is 4, what is the X value of S? Okay, Flavorful Scent went ahead and said it already. If the X value here is 4 for T, what is the X value for S? Yes, guys, the X value for S is 4. Okay, the X value for S is 4. All right, so let's just change it up here. I repeat this again. The X value of T is 4. On a vertical line, who is the same? It's the X value. So that means the X value for S is also going to be what? 4. So that means S here is 4. We just want the Y value. Whilst T is 4 and -1. Yeah. For the vertical length, we need Y at the top so that we can subtract Y at the bottom. Okay. YS minus YT. So how are we going to find then the Y coordinate of S? What are we going to do, guys? We have its X coordinate. The X coordinate of S, we have it. How do we then find the Y coordinate of F? GP Makubela says substitute 4 from the G function and solve for Y. Oh, wow. GP Makakula, GP. Okay, GP, I am so proud. That's like beautiful. Well said. Okay. My brain is not braining, Angelique. The things you guys say, my brain is not braining. Okay, very good. GP Makubela. Okay. You guys said the X value is the same on a vertical line. Since the X value of T is 4, the X value of S is also 4 along the same vertical line. But look at where S is. Where is S situated? Which function is S lying on? Where is it sleeping? Where is S sleeping? On which function is S sleeping? S is sleeping on which function? Where is S having fun? Who is he having fun with? Yes, Zico. Okay. Yeah. Okay. Yes. Flavorful scent, 100%. S lies on G. So if S lies on G and I know the X coordinate of G of S, then it means I'm going to take that X coordinate of S and I'm going to substitute. As Makubela said and Flavorful Scent is now saying, since S lies on G and I know the X coordinate of S, I'm going to take that X coordinate of S and substitute it into the function of G. Then I'm going to get my Y value of who? Of S. Let me repeat that again. T and S are on the same vertical line. When 2 points are on the same vertical line, it means their X values are the same. Let me repeat that again. S and T are on the same vertical line. When 2 points are lying on the same vertical line, it means that their X coordinates are the what? Are the same. But since S lies on G, it is on G, you can take the X value of S, substitute it into the function of G, and you will get the corresponding Y value of X at this point, which is your Y value. So X is equal to 4 into G of X. G of 4 is equal to, now the function of G was X squared minus 9. So let's just say G of X, G of 4 is equal to 4 squared minus 9. Get 16 minus 9, which is 7. Now, to be honest, even though I see now that S is in the same place as D, I didn't know that just by looking at it. So it's good that I didn't assume. When I calculate 16 minus 9, what do I get? I get 7. So G of 4 is equal to 7. That means the coordinates of S are actually 4 and 7. Remember now, I was wanting the distance of T, of S and T. So now I'm going to say ST is equal to Y coordinate of what at the top? S minus Y coordinate of T. 7 minus 1, which is 7 plus 1, which is 8. 8 what? 8 units. Okay. This is so important, guys. Yo. And you do this why? Since S lies on G of X. Sub X is equal to 4 into G of X. And then you get the corresponding what? Y value. So 7 is the corresponding Y value. Now I can say Y at the top, which is S, minus Y at the bottom, which is T. And I get 7 minus 1, which is 8 units. Okay. That's D. That's what, guys? That's ST. Who would have thought that ST would be so nice to find? Let's look at this one, number 7. The length of OM. Where's OM? Here is OM. The length of OM if QR. Where's QR? Okay, I don't see my Q. I don't see my R. Okay, there they are. If QR is equal to 45 over 4, the length of OM, if QR is equal to 45 over 4, the length of OM. Now the reality is, if I can find the X value, guys, okay, either of Q or of R or of M, then the distance of OM is simply an X right, which is O, minus an X left, which is the X coordinate of M. And I would have won the battle. so beautifully. Guys, thank you so much for the likes. 11.9k likes. I really appreciate it. You guys are so kind. Okay, and also the gifts that have been flowing, overflowing with the roses and also forth. You guys can support the live goal. Please do so, especially if you're like new, and if, let's say, for instance, you do have the means to so do. Okay, but if not, please guys continue to double tap, like, comment, and all of that stuff, and just participate, be visible, active, and so forth. Length of OM, if QR is, what are your thoughts, guys? Length of OM, if QR is equal to 45/4. Okay. So I'm given the distance of QR. Okay. And this function at that point minus that function at that point is equal to 45/4. So if I said this function, which is f of x, minus g of x is equal to 45/4, I think we could be able to then set up an equation and then solve for x. And the x values that we get, especially the x values that are negative, those are the x values that we'll consider for q, m, and r, and then length will be x right minus x left, that x coordinate you will have gotten. So what I'm saying, guys, once again, is that they are saying they want the length of OM if QR. Now we need to check, where is QR? Here is Q on the straight line. Here is R, same vertical line on the parabola. So what I'm saying is that at this point, you take the function of the straight line, which is negative x plus 3. I'm going to say f of x minus g of x is equal to 45/4. That is the setup of the equation. Since they are saying the length of OM if QR is equal to 45/4. QR measures the distance from this function to that function at that specific point. Why are we taking the function? It's because we don't have the coordinates of Q. Do you have the coordinates of Q, KB? No. Do you have the coordinates of Q? Because I don't, right? There's no way here that we've been given anything that relates to the coordinate of Q. So the reason why we are using the functions is because this function is at the top, and at this specific point, it represents Q. Minus, because this is like saying y top of this function minus y bottom for the entire function. Hence I'm saying f of x minus g of x equals specifically to that 45/4. So we know that we are exactly here checking the difference between these two functions for this particular distance, okay, that we get for the difference. So f of x and negative x plus 3 minus brackets x squared minus 9 equal to 45/4. Okay, so that's negative x plus 3. Take the negative inside. Then LCD is 4. So you multiply throughout by the LCD. Negative 4x plus 12 minus 4x squared plus 36 is equal to 45. Negative 4x squared, negative 4x squared minus 4x plus 12 plus 36 minus 45 is equal to 0. (48) minus 45. 48 minus 45. Okay, have I simplified correctly, guys? Just double check for me, like the loyal people that you are. Have I simplified correctly, or are there errors that I made? Just check. Okay, I'm gonna give you a chance. Still correct. Are you sure? No errors detected. Okay. So that means life is good. Right. Now, I am doing trial and error. Okay. To get the factorization at this point. But please, guys, remember there is the AC method. 4 times negative 3. 4 times negative 3, you get negative 12. Then you try and choose or find the factors which, when you add, you get positive 4. When you add, you get a positive and a negative. Okay, factors of 12. We have 4 and 3. We have 6 and 2. Specifically, positive 6 and negative 2. The big number having the sign, that's positive. So 6 minus 2. This one will work. So you then rewrite this so that it can replace the 4x there. So 6x minus 2x will replace that 4. So this is another method of factorization. 4x squared plus 6x minus 2x minus 3. Then you look for grouping, you group and you factorize. So for the first two, we have 2x plus 3 minus 2x plus 3. Okay. Common. You see, that's the factorization, which is the same factorization I got here. But we continue. After factors, we apply the 0 factor law. X is equal to half, or x is equal to negative 3 over 2. Now, if you're looking at these two answers, guys, which one is a representation of this side, the x value? Okay. Oh, what did I do here? Look at this, guys. I made an error. Do you see the error that I made? None of them represented, guys. Do you see the... Do you guys see the error that I made? I was supposed to say g of x minus f of x, not f of x minus g of x, because who's at the top? The parabola is at the top. Who's at the bottom? The straight line. So I made an error. I said, oh sorry, oh, it was not for S to that's for QR. Okay, we are right. Sorry, my bad. We are right. But oh yeah. Okay, we are this side. Do you see? My mind shifted now. I was thinking we are here. Okay, so QR, you guys said which represents negative 3 over 2. Yes. Yeah. Okay. I think my brain is slowly but surely going to lockdown. Okay. Going on lockdown. Okay. So we are right. Yeah, that's fine. Sorry guys. I for a moment just got a bit distracted with ST. So x is equal to negative 3 over 2. So we take that x is equal to negative 3 over 2. Okay. And we go and do what with it? It is the x coordinate of m as well. That's negative 3 over 2. Right? So now we have the x coordinate of O, which is 0. We have the x coordinate of m. We want OM. So we say x coordinate of O minus the x coordinate of R. That gives us 0 minus 3 over 2, which is actually 3 over 2 units. This is like 1,5 units. So that's the distance of OM. Distance of OM. X coordinate of M is negative 3 over 2. X coordinate of O is 0. So we say x coordinate of O, which is 0, minus the x coordinate of R, which is minus 3 over 2, which is 3 over 2 units. Okay. Are we cool? Are we coolio? Any questions, guys? Any questions about the length? Any questions at all, guys, about the length? No questions. Okay. Yeah, guys. So let's just be mindful. Let's be mindful of what's happening in each situation. Quintin Jama, can you please elaborate on the length of OM? Okay. All right. So first and foremost, Quintin, when they said calculate the length of OM, they have a provision. They say calculate the length of OM if QR is equal to 45 over 4. So somehow I need to then use the fact that QR is equal to 45 over 4 to calculate the length of OM. So I go to Q, I look at Q and I look at R, and I'm like, there's no coordinates of Q given, there's no coordinates of R given, and there's no way that I can find the coordinates of Q and R just like that. All right, not even by inspection. Like there's no nothing. But what I do notice though is that Q is a point that lies on the straight line and it is above. R is a point that lies on the parabola and it is below. So we are going to say then, if they have told us that the distance of QR is 45 over 4, that means we know what the vertical distance from here to there is. Then I can solve for the value of x for this x value along this vertical line. How? I'm going to take the function of f, which Q lies, and I'm going to subtract the function of G, which are lies. And then when I say f of x, the straight line, minus g of x, the parabola, that is me saying y top minus y bottom, but using the function expression as the means through which, in terms of x, the distance of 45/4 results. So that's why you see me saying f of x minus g of x is equal to 45/4. Substitute the two functions. Obviously, distribute the negative sign inside the bracket to remove the bracket. Okay, because the right thing to always put the bracket after a sign that is negative. Then you write the equation. You can try and get the equation into standard form, as you can see me did here. Then this is an advanced trinomial, right? And as I said, there are various methods. For instance, I used the trial and error method to get the factors, and it's mentally checking the factors of 4, which would be relevant, compared to the factors of 3 that would be relevant, which are a negative sign. That ultimately will lead me to this trinomial. Or another way would be to take 4, the coefficient of x squared, and multiply it by -3. You get -12. Then you look for the factors of -12, which when you add together should give you +4. Yes, the multiplication will give you -12, but when you add them together, let them give you +4. So that's why you have 4 and 3, 6 and 2. We ended up choosing 6 and 2 because 6 minus 2 gives you 4. You then write in x. You take that x, 6x minus 2x, it replaces, guys, it replaces the +4x there in the middle. Then you have -3 at the end. You group factorize. You should get the product of factors. Group factorize, take out the common factor, you should get the product of bracket factors. You solve them, you get two x values, this one and that one. But this one, x is equal to -3/2, best represents what? Best represents the x value along this vertical line. It will be -3/2 everywhere, which means at m, that x coordinate is -3/2. So what you do is you say x right minus x left, xo minus xm. So that will be 0 minus -3/2, which gives you a distance, guys, of 3/2 units. I don't know if you're clear, Quentin Jama. I don't know if you're still around. If you are, please make yourself known that you are. Acknowledgement, maybe a rose. I don't know. You let me know if like it's making sense to you. You said, let me make sense of it. We don't have to use the length formula after we have x values. Well, the thing is, the length formula can be used if you want, but we've just sort of like summarized that for any horizontal line, we can take x on the right, which in this case, we have the x coordinate of O, which is 0, minus x on the left, which is what you found. You found the x value of m, which is -3/2. So for a horizontal line, you can say x right minus x left. Or maybe if you feel like you want to use the distance formula, you can go ahead and use the distance formula. It will still give you 3/2 units. Okay, of course, distance formula is for analytical geometry, but I guess with integration of topics, you can show we won't be marking you incorrect if you so choose to use that, because it's mathematically correct and sound. Okay. I don't know if you have any other questions, Quentin. Okay, let's look at number 8. The values of x. You're welcome. Okay, you're welcome, Quentin. You're welcome. Hopefully you guys can, yeah, man. I appreciate hot meals and stuff. They're really nice. Gifts and stuff. Okay, let's look here. The values of x for which g of x is greater than or equal to 0. Where's g of x? G of x is the parabola. So what's the interpretation of for which values of x is g of x greater than or equal to 0? So here's the interpretation. Okay, I hear you there, flavorful scent. G of x greater than or equal to 0. That means they want to know where is the function of g of x above the x-axis, meaning where is y positive, and also where is it on the x-axis, meaning where is the function exactly found on the x-axis. So those are two things. Where is it above and where is it on? The equal means where is it on. The greater than means where is it above. G of x is the parabola. Okay, so if the parabola is concave up like this, where is the function of g of x above? Where is it greater than or equal? Greater than or equal to the y-axis? Where is it like that? So I'm sure you can see that on this side the function is above. Also on this side the function is above. Okay. NTT is like, well, thank God I switched to my sleep. Yeah, flavorful scent. I see, but yeah, the equal is there. So they want to know where is the function above or on the x-axis. In other words, where is y positive and equal to 0. Okay. Greater than, guys. Okay. Remember, if you go down like this, here the function is above. Then here the function is below. On the x-axis is at 3 and at negative 3. At 3 and at negative 3 they are on. But x less than negative 3, x less than or equal to negative 3 is above and on. X greater than or equal to 3, that's where the functions are above and on. So there are two answers. Okay, where x is less than or equal to negative 3, or where x is greater than or equal to 3. That's where the function of g of x is above, above, x less than or equal to negative 3, x greater than or equal to 3. Okay. Yeah. Okay. If there was a g of x less than, oh please, and here's another thing, guys, you always look at the function that they refer to here. Okay, so since they said g, I'm looking at the function, the parabola alone. If they had said f of x is greater than or equal to 0, then I would look where is this function above the x-axis. So you can see this function of the straight line is above the x-axis where x is less than negative 3. Minute x is less than negative 3, less than negative 3, or equal, then it's above and on. X less than 3, less than or equal, sorry, to 3. But if it was where is g of x less than or equal to 3, remember less than means below the x-axis. Equal means on. So below will be from -3 to 3. You can write it in interval notation or you can write it in inequality form. Okay, it's up to you. All right. Yeah. Guys, I think I'm going to hold it right there for the parabola and the straight line. I think there's been a lot of meat. We shared quite a bit. Okay. I mean, even if you come back here, there's those questions that basically, talk about transformation, For instance, if you look at this function, these two, if I would say describe the transformation of this function to that one, what would you say? Describe the transformation of this function to become that one. What would you say? Y is equal to x squared minus 4 and y is equal to x squared plus 3. How did this function transform to become this one? What happened? Can you guys see what happened? Yes, big Q. This function shifted 7 units up. This one, if you say plus 7 here to this -4, that's like shifting this function from a negative y-intercept to a positive 3 y-intercept. So what happened to the function? It moved up by 7 units. Yes, translated 7 units upwards. Very good. That's also a nice word. Vertically translated 7 units upwards. That's also nice. Shifted 7 units up. Those are good words to use. Yeah. It's like, for instance, if I come here, what happened? Describe in words the transformation of this function to that one. This one to that one. Okay, Big Q says vertically stretched by a factor of 4. Vertically stretched by a factor of 4. Vertically stretched by a factor of 2 now. From here to there. Because the words need to make sense. Y is equal to -x squared minus 2 to y is equal to 4x squared minus 4x squared, plus 4. If you say this thing vertically stretched by a factor of 4, you must understand that this -4 you're multiplying throughout. Then what happened after that? Okay, I hope you see. So it vertically stretched by by a factor of 4, and then it translated 12 units upwards. Yeah, when you vertically stretch it, then it means you are also multiplying this and that. You're not just multiplying -x squared. So then, then it vertically translated 12 units upwards. Okay. Yeah, you must be in the position of being able to do such described transformations. Okay, guys, I think I'm gonna love and leave you. All right. Yeah, that's as much as I can give today. Honestly, I think, yeah, tired at this point, very tired. So I hope you guys, yeah, you gained a thing or two there and there. Okay. And yeah, everything of the best. You write well tomorrow and have fun. Yeah, those who will be writing. Yeah. Kwaka, you're welcome. I appreciate you guys being here and also participating as well as you did. The scent that is flavorful, always a pleasure, always a pleasure having you here. GP Makubela saying it again. I appreciate it. It's very good of you, very kind of you. The words are very kind. Quentin Jama, thank you so much as well. Thanks, guys, for joining in. It was really, I think it was a feast day. It was a McFeast delight. Eh? It was a McFeast delight. Yeah. And also, I want to thank you guys as well for your participation, active, responding in the comment section and just asking questions when it is needed, Yeah. Hopefully, though, guys, everything else that's paper one, man, you guys know how to do. Like, I'm just gonna pierce through, hopefully you know how to identify different types of numbers, you know how to identify real, non-real, rational, irrational, whole number, natural, integer. You can answer questions related to that. Without the use of the calculator, you are able to determine between which two integers does a number lie. You can answer questions related to rational and irrational numbers. You can classify whether a number is rational, irrational, or non-real, based on what you're seeing. Hopefully you can do that. You can rewrite, decimal numbers as a common fraction. Okay. You can round off, numbers to a specific decimal place. You can also convert recurring decimals appropriately using a method, step-by-step method. Convert an appropriate recurring decimal place into a fraction. You can expand, simplify, multiply out, FOIL, binomial by binomial, binomial by trinomial, and mix, where there's many different terms, apply the appropriate rules. Hopefully you guys are good at that. You can factorize, advanced trinomial, all other types grouping, difference of two squares, quadratic trinomial, grouping. Hopefully you can do that. Cubic factorization. Okay, all sorts, different types of cubic factorization. Opening of two brackets, you understand the whole sign composition when you factorize certain, cubic factorization. You can simplify where there is addition of fractions, whether that be numerical denominators, algebraic denominators, when it has subtraction. You can divide fractions, the rules that apply to that. Addition and subtraction of fractions, the rules that apply to that, and so it goes. Division, subtraction, there's all sorts of simplification with that. Exponential expressions, you can deal with exponential expressions, guys, whether it be those ones where you have just divide and multiply alone, or those ones that you have plus and minus in between. Okay, you can then solve for x, can solve equations, you can factorize advanced trinomial, you can factorize, you can solve equations. Okay, hopefully you guys can do that. It's not a train smash. You can solve different types of equations. Simultaneous equations, you can solve equations simultaneously. Hopefully we can do that. Word problems. Okay, you can answer some word problems. Inequalities, different types of inequalities, whether it be those you have to represent on a number line, interval notation, compound inequalities, you can take care of those. Literal equations, okay, making a particular variable the subject, here if you make r the subject, it would mean that you would then write your answer in terms of v, pi, and h, whilst r is isolated. Making h the subject here, meaning you write your subject and then it will be in terms of lambda, e, c, all of these things. Very important things. Sorry, not lambda, just something else there, that symbol. Okay. Yeah, then obviously graphs and functions, description of transformation, being able to also from a description write the equation of the function. Very key, very important. Okay, and of course we've looked at these and some of those, but remember guys, especially in the area or region, we know that we were told that it's parabola and straight line focus for us. So I'm sure you saw. Yeah guys, you see, yeah, hopefully we can, yeah, word problems. The word problems, you see that one has to do with rectangles and area, determine the breadth of the rectangle, different types. So these are just from an exercise worksheet for consolidation for the entire thing. So yeah guys, yeah, all the best, everything of the best. We hope you guys will do well. And yeah, as your Maths is a Game host, I will be in subsequent live lessons actually do all of these, but I think for now it suffices to just have done what I've done today. Okay, let me love and leave you guys. Have a good night, do sleep tight, and please get sufficient rest so that you are alert and awake when you do write tomorrow. Otherwise, from me, hopefully my kids have, I hope that my kids have been able to do every single problem in this paper. It will put you in a very good position, guys. Hopefully you were able to do every single problem, every single one of these, and it's just a flow for you. Because if you haven't, I'm sorry for you, but if you have, good for you. Talking about the algebra, not the functions. When you do paper 2 tomorrow, grade 10. When are you writing paper 2, T? Yeah, if we can do paper 2, just make sure you share the live with your rich aunties and uncles, man. You can come through and come and gift me in the live. I'm also, in as much as I'm doing this, I really like, I'm an avid, gifts are my love language. So come and razzle dazzle. Be happy to oblige. Okay, paper 2 and so forth. Please guys, also just subscribe to my YouTube channel. YouTube channel is around. Okay, I have done paper 2 for grade 10 in the live before, and I've uploaded some of the live lessons that I've done with you guys relating to paper 2. So YouTube channel, definitely a place that you can check out. Otherwise, yeah, we'll definitely be doing paper 2 in subsequent live lessons, because even these kids that are writing tomorrow need paper 2 to be done coming up. Okay, cheers guys, bye.